If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in basic level where you are solving previous year Tripura University questions on method of differentiation. So in this lecture we will be solving from question number 32 to question number 37. Okay, then let's try to solve these questions. Now in question number 32 they are asking to find second derivative when x is given, y is given in this way. So this is again parametric format. So they have given x equal to a theta plus sin theta, y is given a 1 minus cos theta. You have to find d square y by dx square at x equal to pi by 2. At the end, after finding this, we will put theta equal to pi by 2. So for this one, first we have to find dx d theta. So a constant, differentiation of theta is 1, sin theta is cos theta. Differentiation of dy d theta is a constant, 1 is 0, minus cos theta is minus sin theta. So it will be of this fashion. So your dy dx, don't go for second derivative. D square y by dx square is not equal to d square y by d theta square into d theta square by d square theta by d x square. This is not of this format. Second derivative is not. You have to take first derivative, then you have to take again more differentiation, then it will come. Don't take directly second derivative of this second derivative and then divide. No, it is not like the first derivative. So that you have to be careful. So dy dx is dy d theta, that is a sin theta, divided by dx d theta, a 1 plus cos theta. So a get cancelled. Now you take derivative of again differentiating with respect to x. So it will be d square y by dx square, and here because it is theta you are differentiating with respect to x. So first derivative with respect to theta, and at the end you do d theta dx. You are doing d theta then d theta dx. So if you differentiate it on this one with respect to theta, u by v format, so denominator constant, numerator differentiation sin theta is cos theta minus numerator constant, differentiation of denominator, 1 is 0, cos theta is minus sin theta. So it will be 1 plus cos square theta plus sin square theta by 1 plus cos theta whole square, and this one we have already seen d theta dx, that is inverse of this one, 1 by dx d theta, that is a 1 plus cos theta. It will be a square plus a square 1, cos square plus sin square 1, so 1 plus 1 2 by 1 plus cos theta whole cube a. So they are asking you to find at, they have given theta also value, at theta equal to pi by 2. So if you put theta pi by 2 here, 1 plus cos pi by 2 whole cube, cos 90 is 0, so it will be 1, so 2 by a. So that is your answer. Now they are asking to find the derivative of this following function with respect to x. So they have given y is equal to x tan x log x. So there are three functions. So you have to find dy dx. So how we will take? First you can take these two constant, x tan x, differentiation of log x 1 by x. U by v, u into v I am doing. This is u, this is v. Next you take log x constant, differentiation of d dx of x tan x. Because here you have to apply again u into v. So it will be x cancelled. So tan x plus log x into, here first you take x constant, d dx of tan x is sec square x plus tan x constant, dd of x is 1 into 1 I am not writing. So this is your answer. So when there is a three product, you take first any two constant as a u, and then second one is v. So you do u into v. So this constant differentiation of this, then second one constant differentiation of that two product. Here also you have to apply u into v. This is outside, so first this constant x constant differentiation of this plus this constant differentiation of x is 1. I am not writing that one. So this is your answer. So in question number 34, dy dx, find where y is equal to this at x equal to pi by 4. Again this is on the top of another one, so you have to bring it to the earth, and then you can differentiate it. So given y is equal to tan x to the power sin x, you have to find dy dx at x equal to pi by 4. So first you take log of y. So if you take log, this sin x will come in front and this will be log tan x. Next you differentiate with respect to y. So this is 1 by y dy dx. If you take sin x constant, differentiation of log is 1 by x. Then you have to differentiate again, tan x is sec square x plus log tan x is constant. You have to do differentiation of sin x is cos x. So your dy dx equal to y into this. Y is your tan x to the power sin x, this into this, sin x sec square x tan x plus log tan x cos x. You have to do everything on dy dx at x equal to pi by 4. So you put x equal to pi by 4. So tan pi by 4 is 1. Sin pi by 4 is 1 by root 2. So anything 1 to the power is always 1. So this will be 1. Sin pi by 4 is 1 by root 2. Cos pi by sec pi by 4 is root 2 and root 2 whole square. Tan pi by 4 is 1. Log 1 is 0 because tan pi by 4 is 1. Cos pi by 4 is 1 by root 2. So this will be 1 and this will be root 2. So 1 root 2 will be there and this is 0 because log 1 is 0. So answer is root 2. Next in question number 35, y is equal to this, then prove this. So y is equal to e to the power x log x, and you have to prove x y2 minus 2x minus 1 y1. This one you have to prove. So again differentiate. Log x is 1 by x. If I take e to the power x constant, then log x, if I take constant, differentiation of e to the power x is e to the power x. So before proceeding further, you need 1x with that. So that's why I am giving x that side. Suppose I have taken LCM. So it will be e to the power x, then x into e to the power x log x. So that is e to the power x, and e to the power x log x you can again put y. I have taken x as an LCM, so x will come here. That x I have sent that side. Now you differentiate again with respect to x. So it will be x constant, then differentiation of y1 is y2 plus y1 constant, differentiation of x is 1. E to the power x differentiation is e to the power x. X constant, differentiation of y is y1 plus y constant, differentiation of x is 1, u into v. So if you take y1 in one side, so it will be, write it y2 x y2 plus y1 is equal to e to the power x plus x y1 plus y. Okay, once we have derived it with respect to x now second time, then we are getting this one. Now if you see your proof, this is your proof. You can see everything is coming here, but there is no e to the power x. So try to eliminate this e to the power x from this expression, because in the proof there is no e to the power x. So you can find this e to the power x from here, because if you use this one, then you will get this 2x y1 that, and you will also get xy term, because here there is no xy term. If you are replacing this one, then again log x will come, but there is no log x. So I will replace e to the power x from here. So from here e to the power x is equal to xy1 minus xy. So I will use this one. From a, if you put this one, this will be xy2 plus y1 plus e to the power x. You will put xy1 minus xy plus xy1 plus y. So it will be 2xy1, and then if you take minus xy plus y. So if you bring everything here now, xy2 plus, if you take y1 common, in fact if I take minus common, then it will be 2x minus 1 y1, because it will be minus 2x. Then if you open it, then you can see it is plus y1, and if you bring this one this side, then if you take y common, it will be x minus 1 y is equal to 0, which is proved. Now if you come to question number 36, find the derivative of these with respect to z. Again, that means derivative of one function with respect to another function. So let me take y is equal to sine inverse 2x by 1 plus x square, and z is equal to cos inverse 1 minus x square by 1 plus x square. So they are asking dy dz. So I know how we will solve it, dy dx, then dz dx, because there is no direct relation between y and z. So you cannot differentiate dy directly with respect to z. So you have to do first with respect to x here, with respect to x, then you divide dx dx with cancel, you will something getting dy dz. So for this one you have to assume let x equal to tan theta, because it is 2 tan theta by 1 plus tan square theta. You have seen it is sine 2 theta. So we have already done this one also. This one is sine 2 theta, sine inverse and sine will get cancel, which will be 2 theta. 2 theta will be tan inverse x. Here also if you put again let x equal to tan theta also, then it will be cos inverse 1 minus, this one also we have done, tan square theta by 1 plus tan square theta, which is cos 2 theta. Again this will give you cos inverse cos 2 theta 2 theta, which will give you 2 tan inverse x. So if you differentiation dy dx, it will be 2 by 2 into 1 by 1 plus x square. Here also if you differentiate dz with respect to dx, then it is 2 into 1 by 1 plus x square. So therefore dy dz is equal to dy dx divided by dz dx. So if you divide this one, same thing will be dividing 2 by 1 plus x square into 1 plus x square by 2. So answer will be 1. So this is your answer. Now if you see 37, if y is equal to this, half means root x. So it is given y is equal to root x plus 1 by root x. You can write it this way. We have solved this one. or you can write it x to the power half 1 by x to the power half, whatever you feel better. You can write it x to the power half. This one is x to the power minus half, because from denominator you can bring it numerator. So if you are differentiating with respect to x, you have seen for root x it is 1 by 2 root x. For because it is root x, so it is 1 by 2 root x. You have already seen. And x to the power minus half, it is minus half x to the power minus half minus 1, which will give you 1 by 2 root x plus that is minus 1 by 2 x to the power minus 3 by 2. What is minus 3 by 2? 3 by 2 means 1 and half. 1 full and half. 1 full and 1 half. Half means root, because minus they will come denominator. So you can take LCM 1 by 2 root x. If you take LCM, then it is 1 by 1 minus x. So you can keep it as it is, because it is just they are asking to find this one, no proof. So this is your answer. If you like the video, then press the like button and please give your valuable comments in the comment section.